we don't want our answer to be in terms of u at the end. We want it to be in terms of x. So all we have to do here is just replace our u back with x squared plus 1. And that would be our answer. Oh, sorry. Thank you. Yes. So, and you can check really easily to see if it does work. 3 times 1/3 would be 1 x squared plus 1 to the second power times the derivative of the inside, which would be 2x. So it gives you what you started with from the beginning. It doesn't have dx there, but
So you're basically just using u as a placeholder.
yeah, u is your placeholder for you to work backwards here. How did I get what? What I just wrote in red. I was just taking the derivative to see if I got what I started with. Because we've integrated here, so to go back to the original problem, we take the derivative to see if we got what we started with. All right, let's try another one.
Is u the 5x?
Okay. All right, so the inside part on this one, it's usually what's inside some sort of parentheses or something. In this case, it is. So those of you that said u was our 5x, you were correct. So u equals 5x. So the du dx would be just 5. We're going to put that dx over here with it. All right. So I see I've got u. I do have this 5 right here. It's not with my dx, but could I just take it and put it over here with my dx? Be perfectly fine. I'm going to rewrite it just so everybody's really clear on what's happening here. You don't have to show this step necessarily. So here, this is our u, and this part right here is our du. And so we're integrating cosine of u du. What is the integral of cosine? Sine of u plus c. And then we want this to be back in terms of x, so we just replace sine the u back with our 5x plus c. Where at? Yes, that's 5x. Whenever you integrate, so like in this step we're actually doing the integrating. When you integrate the du, mathematically this is not exactly right to say, but it basically gets replaced with that plus c. Because the integral and the derivative cancel each other out, we just replace it with that plus c. Yes. Correct. So if we're taking derivative of cosine would get negative sign. But integral of cosine is positive sign. Okay, questions? All right, let's look what happens if we don't have everything we need for the du. It's not that bad. We'll just get it. All right, so copy this one down for me. We're not going to distribute, although technically you could square this out and distribute. But what you're going to see for these is that usually whenever we do this, it's on multiple choice, or a lot of times anyway. And the answer choices will not be multiplied out. They'll be still factored, well, so it's been done with a UDU substitution. So if you do multiply this all out and integrate it, then you'd have to do like some crazy factoring to get back to what the answer choices are going to look like. So something like this, you want to use a UDU substitution on. Selena, what's the inside part? What's the U going to be for this one? Very good. And so our du, what's that going to be? Not just x, 2x. And I'm going to go ahead, is it okay with you guys if I go ahead and just put that dx over here? Okay, because it's not coming from the original problem. We're taking the derivative of x squared plus 1. Derivative of x squared is 2x.
That's what the d stands for. Derivative.
And then normally, so I'm going to start doing it this way where I just go ahead and put that dx on the end. What's happening is it was du dx equals 2x, and I'm multiplying the dx over here to the other side. So the dx is on that right-hand side. So that's what I'm doing when I put the dx over on the other side. Yes? We'll see a few of those coming up. I don't know that we'll see them today. Sometimes you sort of have to guess, and then if it doesn't work, try something else. I don't know that we'll see them today. I think the ones today are a little more straightforward. Okay, so we know this part right here is u. What's our problem? I can take this x and put it over here with this dx, but what am I missing? The 2. So I'm going to write it like this. Integral of x. Let's see. I need space right there. X squared plus 1 squared. I'm going to put my x dx over here. Move the x over there with my dx. But I have to put a 2 right here. But I can't just multiply by 2 here without canceling that out somewhere, right? You're close, Daniel, but not a 4. So if all I got to do is put a 1/2 out here. What is 1/2? Well,
because you can bring it out.
Why would you use 1/6?
Because like 1/6 and then x side and then to the power of 3.
Why to the power of 3?
Because that's the inverse.
Don't integrate anything yet. Okay? So all we're doing is we need a 2 here because it's missing. So since that 2 is missing, if we put 1 over 2 out front, 1/2 times 2 equals 1. We haven't changed the value of anything because we've multiplied by 1.
Right, so really this is like adding an understood one. But like more complicated.
Right. Right. So like,
Because
yeah.
really at any point you could also add an understood 1/2 and 2.
Correct.
That's incredible.
Yeah.
I like that so much.
Woo. Maybe when you're done, maybe. But right now it's just 1/2. All right. So, and I wrote the 1/2 on the outside because I don't want it messing stuff up in here. But I could have done 2 times 1/2 right here. 2 times 1/2 just equals 1, so it doesn't change anything if I multiply by 1. And then I could take that 1/2 and pull it out front because it's a coefficient. All right, so since these are just coefficients, we can just multiply by the 2 on the inside and the 1/2 on the outside, and they cancel each other out, and we haven't actually changed the value. I mostly put it before the sign because I don't want it to be on the inside when I'm integrating. Because if it's on the inside when I'm integrating, then it sort of complicates what I'm having to do there. Technically, I could put it there, and it would still be okay. All right, so this part right here is my U. This part right here, now I have everything I need for my DU. So whenever I change this using substitution, I will have the 1/2 that still stays out front. I will have U squared DU. All right, and then we're just going to integrate. So increase your exponent by 1 to get 3. Multiply out front by the 1/3. Put the plus C on the end. And so we will get 1/6 U to the 3rd plus C. And we can replace our U back with our X. Do not forget the C. Obviously, lots of other calculus teachers are teaching this right now as well, because there's been a lot of plus C jokes and memes on the AP calculus. He occasionally posts. The one that posts the most is the Mark Corrali guy. He really, I wonder if he still actually teaches class, because he like responds to every single post of every person that posts. He obviously is very he is very active in the Facebook group. But I mean, like he makes the videos for AP Classroom and stuff. Like I consider him to be a very highly respected authority. So if he answers something, I just assume it's right.
You never told us if they thought 2 was prime or not.
Oh, I gotta look that up. It is your DU, and DU basically turns to the plus C. Yeah. Yeah, it must be there in order for you to integrate. If it's not there, then you can't integrate. But once it is there, it just basically turns to your plus C. Usually they're not going to like multiply this back out or anything. They usually just leave it here. Yes? Like, how can you tell the difference between this and just like the problems we've been doing before?
Like, how do you know not to plug the U in at like the first step? I mean, plug the stuff into the U.
So before you can integrate, you have to have a U here and the DU both have to be there. And then once you have changed everything so there's no more X's anymore, and everything's in use, then you can just integrate using the power rule. Okay, here's our next one. All right, so Emerson, what should our U be for this one? Very good.
When moving it up,
It's fine. You can move it up if you want. But you still are going to have to use U substitution on it. Yeah. So you can leave it in the bottom or you can move it up to the top. Either one's fine. Perfect. All right, so let's think about what we got here. I got a u right here. I don't have anything with my dx. I need a 3 with that dx. So I need to put a 3 right here. Let me use red so I know that I'm adding that in. I can't just put a 3 here. I got to put a 1/3 out here to balance that out. Okay, so I'm going to have 1/3 integral of 1 over u squared du, because we have already that stuff right there is u. This stuff right here is du. You may want to write it like this. So the du is 3 dx. So the 3 has to be there with it. So it's not like just like the dx turned into a du. You have to have that whole expression. So that way we don't have a 3 over here. No. All right. And you could have done this from the beginning or now. I would probably make this u to the -2 du. To integrate that, we're going to increase our exponent by 1, which will give us a -1. Divide that 1/3 by -1, so we get -1/3 u to the -1 plus c. You might move the u back down to the bottom, and then you certainly at the end have to replace your u with your x expression, so 3x minus 5. They might leave it like this. They might multiply that back out and get 9x minus 15. It just depends on what answer choices look like. If it is free response, as soon as you replace your x, you can leave, oh, what have I done? What have I done? What's wrong about this? I had a plus c and then I lost it, so make sure you don't lose your plus c. I'm gonna do this on the last one. I'll show you guys. It makes my skin crawl just a little bit. We heard meowing. I don't know. All right. Probably not. Sometimes they bark at the dog, but I don't know that they meow at the cat. Yeah. Yeah. Okay. So if you move over here to get the dx, you would be integrating both sides. So essentially you're just integrating this. What should we do here? What can our u be? Let's try what Ethan said. What would our derivative be? Now, are we going to be able to do that? You can add in coefficients, but I can't put that, like I can't multiply by 1 plus 4x here and 1 over 1 plus 4x here. I can't do that because that expression has an x in it. So it works with coefficients. What? Okay, So make it x plus 2x squared over x to the 1/2 dx, and let the x to the 1/2 be my du or my u. So du would be 1/2 x to the negative 1/2, which is 1 over, with the dx, 1 over. Okay, so we're running into a brick wall trying to use u substitution. What did Addison say we should just do? It is Valentine's Day. Alright, this is not a u substitution problem. You can't use u substitution on this. The textbook has put some like landmine problems in there where you don't actually have to use u substitution. So it's going to look like this. So this would be x to the 1/2 plus 2x to the 3/2 dx. And so you just use power rule on this. X to the 3/2. You're going to have to divide out front by 3/2. Here we'll have x to the 5/2. Divide out front by 5/2. Don't forget your plus c. Oh, I was going to do this. Minus c. Can I do that? I can, because c is unknown, so it can be anything. I could put minus c plus 5 if I wanted to. Yeah, because c is still, this whole thing right here is just a constant that we don't know what it is. So it makes my skin crawl to even see this written, to put a minus c, but it was being discussed on the Facebook page the other day. It's okay to put a minus c. It's the same as a plus c. But let's go back to plus c because... You could, yes.
Can I do like plus the square root of c divided by the integral of tan theta?
You couldn't introduce a new variable, so you couldn't put a theta.
But you could write it as 1 over the cube root of c squared.
I think it might. Could it be a negative number?
That's tricky.
It couldn't be negative because you're squaring that c. Yeah, so, but you could add something like plus 5c cubed. That'd be okay. I'd be careful with I would just put a plus c. I wouldn't do any of this crazy stuff. But you would not want to use a root because you can't take roots of negatives. You probably don't want to use a square because if you use a square, then it can't be negative. That value can't be negative. So, sign has to be between positive and negative 1. So, no, I wouldn't do sign. I wouldn't do any of this. I would just put a plus c. I just wanted to point out that technically that could be anything right there. Mark Corrali likes to put minus c sometimes. Yeah. And then here we got 2 times 2 over 5, so we get 4/5 x to the 5/2 plus c, or you can use minus c, or plus c minus 7. Just if you want to make me shudder a little bit as I'm grading stuff. She working at the rescue squad. Yeah. She might be. Yeah. Okay. All right. So, your assignments. Let me look at this and make sure this is what I want. Alright, so the first few should be pretty quick because you already have your DU. It should go pretty fast. When you get to some of the later ones, it might take a little bit more. 23 is a little bit of a challenge problem, but I want you to try it. I will not give you credit if you don't at least try something for 23. You will not get full credit. 3.5 if you don't at least try something. Okay? So, you got 10 minutes. I want everybody to be working on the problem right now. Everyone.